The rational zero theorem will help us to be able to factor larger polynomials. What the rational zero theorem says that if we have a big ugly polynomial with however many terms in it, if that polynomial has a rational zero, then it has to look like this, p over q. Because it's rational, it can be written as a fraction. But the thing about it is that p, our numerator, has to be a factor of the constant term a sub 0. And q is going to be a factor of the leading coefficient, which is nice. So what it allows us to do is that instead of having infinitely many possible rational zeros, we can narrow down that list from infinity down to a handful. So let's take a look at f of x equals x cubed minus 8x squared plus 11x plus 20. First thing, list all the possible rational zeros. Well, remember, if there are any rational zeros of f of x, the numerator would have to be a factor of the constant term. So it's either going to be plus or minus 1, 2, 4, 5, 10, or 20. Because all of those are the factors of 20. And the denominator would have to be a factor of our leading coefficient, which is just 1. It's kind of nice because that means our list is full of just integers, all the integers being 1, 2, 4, 5, 10, or 20. So, we can use that list to help us factor f of x completely. And we'll do that using synthetic division. So we'll take all the coefficients of f of x, 1, negative 8, 11, and 20, and set up our synthetic division. Since we have this list of possible rational zeros, let's just go ahead and start trying them. So the first thing I'm going to try is just 1. So we bring down this 1, multiply and add, multiply and add, multiply and add. Since our remainder is not 0, that means that 1 is not a 0 of f of x. So we'll just continue through our list. The next one I'll do is negative 1. So we bring down negative 1, we'll bring down 1, multiply by negative 1, and add. Multiply by negative 1, and add. Multiply by negative 1, and add. Now we did get a remainder of 0, which means negative 1 is a 0. Furthermore, what it means is that x minus negative 1, or x plus 1, is a factor of f of x. The other factor would be that, x squared minus 9x plus 20. Since we have this thing factored down so that we have one of our factors being a quadratic, we know how to factor a quadratic. We'll break that into its two binomials and factor x squared into x and x. Factor 20 into 4 and 5. We want to make a negative 9 out of it, so they both need to be negative. Now that we have it completely factored, it's easy to see where all the real zeros of f of x are. Because if x plus 1 is a factor, that means negative 1 is a 0. If x minus 4 is a factor, positive 4 is a 0. And if x minus 5 is a factor, positive 5 is a 0. And there are all of our zeros of f of x. Let's do it one more time. This time let g of x equal 2x cubed minus 3x squared minus 14x plus 15. The first thing we want to do is list all possible rational zeros. Well, our numerator would be all factors of 15. So that's 1, 3, 5, and 15. The denominator would have to be a factor of 2. So it's plus or minus 1 or plus or minus 2. Now, with a couple things in the denominator, that means that our entire list of possible rational zeros are first going to start with the integers, plus or minus 1, 3, 5, and 15. Or we can continue with all of those being divided by 2. So 3 halves, 5 halves, and 15 halves. I know that now you're freaked out with this, that our list is so long and it's got fractions in it. just go right into trying something out. So set up your synthetic division with all of the coefficients, 2, -3, -14, and 15. And just start trying something. I'm going to start with 1. Bring down the 2, multiply and add, multiply and add, multiply and add. And we got lucky. Right off the bat, we found a 0. So if 1 gives us a 0, that means that we can start factoring g of x. And if 1 is a 0, that means x minus 1 is a factor. And the other factor would be 2x squared minus x minus 15 from right here. We can continue with x minus 1 and factor this quadratic. 2x squared gets factored into 2x and x. 15 will factor into 5 and 3. We'll need -6 plus 5 to make the -1 in the middle. Now this thing is not completely factored. It's factored, and your book would probably say it is completely factored, but I don't. What I want is every leading coefficient to be 1. So since I have 2x right here, what I want to do is take that 2 all the way out. X minus 1 will stay the same, and x minus 3 will stay the same. But when I'm going to factor that 2 out of our middle factor. So how we factor something out is by division. We're divided out of 2x. So I'm going to divide 2x by 2, and I'm left with x. Divide 5 by 2, and we're left with 5 halves. Now we can easily find all the real zeros of g of x by looking at the factors. If x minus 1 is a factor, 1 is a 0. If x plus 5 halves is a factor, -5 halves is a 0. And if x minus 3 is a factor, 3 is a 0. And we're done.